because I think I read that in ancient times when people do bibliometrics, they are literally counting with bare hands through the paper publications. And also in many other computational social science research topics, we need to manually scrape the data from either APIs through social media like Twitter or Facebook. And in a lot of those cases, we are dealing with essentially very messy data. We need to manually clean text. But because science is such an important topic, there are someone else who already scraped the data for us and curate the dataset for us. So there are a lot of very famous dataset for science, to name a few, Web of Science. But Web of Science is not free. It's not open in the sense that we need to pay a small fee in order to use that. So before 2022, there was a dataset, as Daniel mentioned, called Microsoft Academic Graph. But it is good, it's openly accessible, and it's a huge database. But the only bad thing about it is now discontinued. So the database I'm going to talk about today, called OpenAlex, is the successor of that Microsoft Academic Graph. So as described, now I'm going to give you a bit of the general information of what is OpenAlex. So OpenAlex is a database with a lot of scientific related data. So there are 4 main entities in that database. So we have works, authors, venues, and institutions. So this is a very initial representation of what the database looks like. But if you will pull the data to a relational database, it actually looks like this. So there are roughly 26 tables in the database. It's a huge database. So I think if you download the entire dataset, it will be around 300 gigabytes. So I'm going to walk through each of the entities. So the first thing is works. So I guess some of you might have experience working with other scientific databases like Microsoft Academic Graph. So usually research work are only represented as papers. But for OpenAlex, we have works which represents not just papers, but also books, datasets, which are, I guess datasets are usually underrepresented in other scientific datasets. And I think a very good resources. So OpenAlex is very open in the sense that they not only open their dataset, but also their code to scrape data. And they also have a very good documentation. So I will encourage you to also look at the documentation of OpenAlex. Let me put in, I guess I'll put in the chat or Zoom. So there's a lot of information about each entities in the database. So for OpenAlex, they have done a lot of work to disambiguate words, authors, etc. So they have their own identifier, meaning that for each ID, there's a corresponding work. But they also link the works in OpenAlex to external IDs, so maybe you're more familiar with Microsoft Academic Graph. They also have the mapping between OpenAlex works with paper IDs in Mac. And maybe you're more familiar with PubMed data. They also have the external link. The second entity in OpenAlex is authors. Authors are those who created works, either their papers, books, or datasets. There is also a list of external IDs aside from OpenAlex IDs. So instead of other IDs from other well-known scientific databases, they also have gathered, I believe they're still working on it, a Twitter data handle and Wikipedia URLs for all the pages if they have it. And the third entity is venues. So in many other scientific databases, they usually have journals alongside with conferences. But in OpenAlex, they have venues including journals and conferences, and also there are many paper repositories such as archives. So they also have many external links. And we also have institutions. Those are organizations to which authors claim affiliations. And they have our ID. I think all of the IDs in OpenAlex are pulled from many different databases, such as MAC, Crossref, and I'm not sure it's Semantic Scholar. And the last entity is concepts. In other words, ideas, school of thoughts, or fields. So I think it is based on the fields in Microsoft Academic Graph. In that case, they just use large language corpus from abstract and do a topic modeling and assign concepts. And in terms of concepts, they're actually a tree. So let me show you. So as I speak, it is a tree in the sense that the concepts have different levels. So for level 0, those are more general concepts like history, physics, mathematics. And with higher levels, we have more niche concepts like surgery, microbiology. Let's see. Okay, I got questions from the chat, but institutions disambiguated. I think that they're working on authors disambiguation, but I think they're still working on it because it's a very hard task. How are concepts levels for words derived? I think for each work, they will include different levels of concepts. Like they will include a list of concepts. Okay. For authors, I think so. I think they will just check what the author published in the last few years and decide the concepts. Yeah, I think they're still working for it. Oh, I thought you mean concepts for authors. Yes, I forgot where I was. Okay, the concepts. So they're basically a tree. So with level 0, there are more general concepts, and there are a lot of concepts, but we will see more about it when we walk through how to access the dataset. So I think under the folder of 1- introduction, there's a Hyperphone notebook called OpenAlex. You open it. So I'm going to walk through how to access OpenAlex, either through the sample we have in the environment or through API. So there are two main ways to get OpenAlex. One is to download the entire dataset, which is 300 gigabytes, and the other is using the official API. So in order to let all of you have a sense of how it works, there is a sample in our environment under this folder. So the size of the sample is about lower than 1 gigabyte. But so for each environment, I think each of you are limited to using only under 8 gigabytes of memory. So you might have some trouble joining large tables. But feel free to try out. So in this example, we're going to use pandas, which is a tool that you can work with tabular data. So each files under this directory, they are tabular data tables, tabular data. So imagine yourself working with Excel cheat sheet. So it looks similar. So I think tomorrow we'll discuss more in depth about pandas. But in this cell, I am reading the data using pandas. So we can get a look of how the data looks like in tabular form. But tomorrow, I think we will talk more in depth of how to manipulate data using NumPy and pandas. And the reason we are only taking a small sample of OpenAlex is that, as I mentioned, it's 300 gigabytes and is oftentimes not realistic for us to just manually use the entire dataset. So alternatively, we can use the API provided by OpenAlex. So API, application programming interface. So there's a server hosted by OpenAlex that hosts the entire dataset of OpenAlex. So what we will do with API is that we send requests to the server asking for the data we need, and they will send them back to our own computer. So there are several different things that we can ask for the OpenAlex server. We can either ask for one single record, for example, a single word. So here I'm importing the packages. I believe tomorrow will be more in-depth introduction, but basically we're importing packages. So I have questions from chat. I don't think pictures data are included. Yes, citation is included. So I guess I'll work through in depth about what each entity includes. So for work, there's referenced works. So for each work, there are a list of publication referenced by the work. So from there, we can create a citation network. And for those who are interested in using textual data, there's also inverted index of the abstract for each work. Okay. So the data are in target form, but usually most of the data I think are in CSV. But in order to read target files, we need to install packages in the environment. So PyArrow is the package that enables pandas to read target files. Between this data and Mac. So Microsoft Academic Graph was hosted. Mac is free, I believe. Yes, I think in order to download Microsoft Academic Graph from the S3 bucket, you need to pay, or Azure. But in order to download OpenAlex, yes, Mac was discontinued last year. And I think there are more information in OpenAlex website that walks you through how you can download the snapshot of the entire data set. And the process is entirely free. Yes, I think each time I start the server, I need to install PyArrow. So for CSV files, we can just read the files out of the box, but in order to read PuTTY files, we need to install PyArrow. Oh, right.
I think you can use the single the tilde instead of the dot.
I'm not sure. Oh, right. Yes. Use it here. Okay, so in order to demonstrate how to just pick one entity object from using the API, I will just randomly pick one, or not randomly, just pick one work from our sample. So I'm picking this publication, published in 2016. So the OpenAlex ID, they're actually a URL. You can access it. So OpenAlex is working on the web page version of the entire dataset where you can access a lot of information about the works, but it's still under construction. So the ID is basically the URL pointing to this web page. But the actual identifier is the last bit of the URL. So to construct an API, the base URL, base URL for the API is this. We'll construct the URL with this format if we want to get a single entity, a single object from an entity. So we want to retrieve a work and then follow with the entity ID, which is the last bit of the OpenAlex ID. We use request, which we imported. And then the response from that request is actually in JSON format, so we parse it. And the returned object is actually a dictionary. So we can access each values in the dictionary through the keys. So instead of work, we can also work with other entities. So there's functionality from the API, which we can just retrieve a random object For example, we want to just retrieve a random values from the API. So each time you run this, you will return a different value. So if I run it again, it should return a different value. So it will be a little bit slow to just retrieve the object one at a time. So many of you will want to work with a total list of applications that you are interested. But I also want to mention that sometimes it's more convenient to just download the entire data set if you have the computational power. But now I will just walk you through how you can, if you have predefined condition to retrieve the data, you can also retrieve a list from using the API. So what I just did was, instead of defining entity ID after entity name, I made a call, and it will not return everything. You'll just return a limited amount of objects from that entity. But it doesn't make any sense unless we have a condition of what kind of objects we want to get. So in order to make any meaningful search, we'll make use of functions from the API called filter, search, and sort. So to give an example, so we just talk about concepts entity, which is like research IDs, research fields. And we want to know what are the level 0, the highest level concepts or the most general topics. The way we can do that is to use filters. So the filter parameters could be formatted like this way. So we need to identify an attribute along with the values that we want it to be. For example, if we go back to the OpenAlex document, for the entity, there's a feature called level. So with the filter, we put level here. And then, because we want to retrieve the most general concepts, we put 0 after level, comma. So the returned object is a dictionary. So we can just retrieve the values by calling the keys. And we want to print out all the display name of the most general concepts. Those are the level 0 concepts. And instead of using equal, there are other operations that we can use. For example, we want to know that what are the works that, what are venues that are large in the sense that they have published over 1,000 works. So we can construct the API like this with larger operation. So it didn't return the metadata for each venues, but all those venues have more than 1,000 words. And aside with equal and larger and smaller, you can also put unequal operation. So for instance, we want to get a sample of institutions that are outside of the US. Construct the filters. Yes. And you will return a long list of affiliations or institutions that are not from the US. So country code is also a featured institution. So aside from filter, we can also do search like we did for the search engines. For example, I want to get all the authors named Leibniz in the author's entity. So for filter, I want to identify a features called display name, which is supposed to put the names of the authors, and then I put dot search, and it will return to all the authors with Leibniz in their names. And as you can see, there are a lot more works that OpenAlex should do to do author disaggregation. And aside from filters and search, we can also sort. So sometimes there are many metrics, like so for example, citation counts. We want to order the whole list so that, for example, we want to see what are the most popular works in the sense that they got cited more often or more times. So using this API search, I add a filter so that it returned publications that are published after 2010. And also I added search, sort, so that the returned result will sort by the number of times work get cited in a descending order, so that the publications that got cited more times are in the front. So this call will return the most popular papers published after 2010. And many of you might have experience working with SQL database. In those cases, you want to group by. For results, you want to group them into faucets. And group by is also functioned for the API. So for works in OpenAlex, there's a feature called Open Access Status. So we want to know the distribution of open access status in OpenAlex. So what we do is just to put open access OA status as the group by term. And then the result would return the distribution of open access status of all the works in OpenAlex. Okay, so I have another example in the library from OpenAlex. This is a more complicated use case of the API. And at the end, you get a very nice visualization of the percentage of open access work in your affiliation or institution. So, but it will involve using matplotlib. So feel free to try it out yourself. Any questions? Okay, Thank you.
Thank you, Shen. Very, very useful. I didn't know that you could do all those queries. Okay, so if you have questions for Lijian, you can ask him on Slack, and he'll be happy to answer them. This notebook is on GitHub and also copied to your environment. And in my opinion, this is the way to go for your projects. Okay, so we're going to take a break and we'll come back at 1:30 p.m. So that will be like 35 minutes from now, and to discuss the projects. So see you then. Bye. Well, we'll look for Steve, and I will share the two things. So one is, let's see. So the course material and that I'm presenting is also available if you go to GitHub. Lectures. So if you go here to this link, and I will post it on Slack, you can access everything. So if you go here to references, you'll have the proposal guidelines and the mini grant description. And that's what we hope to go through now. And I'll pause the recording. Let's see what's happening with Steve. I was explaining how to access the proposal guidelines, but you'll do it more properly.
Okay. Yeah, and we'll get started. Yeah, let's see. Well, I'll make sure we get that. Everyone has